Do you want to know a secret?
Formula. It is a noun which refers into mathematical relationships or rules expressed in symbols. It usually connects two or more quantities with equal sign. Wait! In this video, we are going to derive some of them. Let's do this!
This is the secret formula, where we are going to derive some of the most common formulas in mathematics. Or better yet, let's call this the secret in the formula. What formula are we going to derive on this video? Slot machine, go! It is the Polygon Angle Sum Formula, which states that S is equal to the product of n minus 2 and 180 degrees. This video is aligned to the K-12 Math Curriculum Guide specifically for grade 7, where we are required to derive inductively the relationship of the interior angles of a polygon. To start, let us answer this short pretest. Number 1. In the formula, what does the variable n represent? Is it A, the number of diagonals, or B, the number of sides? What if it's C, the sum of interior angles, or letter D, the measure of sides? 5 seconds. Time is up. Let's proceed to number 2. Question number 2. Which theorem states that the sum of the measurements or measures of the interior angles of a triangle is equal to 180 degrees? Is it A, the triangle angle sum theorem, or B, the Pythagorean theorem, or is it C, the exterior angle theorem, or how about letter D, isosceles triangle theorem? 5 seconds. Time is up. Let us go to question number 3. Question number 3. What term refers to a line segment that is drawn by connecting any two non-consecutive vertices of a polygon? Is it A, side, B, leg, C, base, or letter D, diagonal? 5 seconds. Time is up. Question number 4. For 5 seconds. In the derivation process, what is the relationship between the number of the triangles formed and the number of sides of a polygon? Letter A. Number of sides is 2 more than the number of triangles formed. Letter B. The number of sides is 1 more than the number of triangles formed. C. The number of sides is the same as the number of the triangles formed. Or letter D. The number of sides is 2 less than the number of triangles formed. On to our last question for this pretest. Please keep your answers, as we are going to determine later on if your answers are correct. Question number 5. What is the sum of the measures or measurements of all the interior angles of an octagon? Is it A, 180 degrees, B, 360 degrees, C, 1080 degrees, or letter D, 1440 degrees? 5 seconds. Time's up. Aside from the pretest, there are also guide questions that will help us understand this video. Number 1. What is this formula all about? Number 2. Which math concept is this formula based on? Number 3. How was the math concept used and the derivation? And the last question, what reasoning procedure created the formula? Please use these guide questions all throughout. Let's start with the first part of this video. Let's take a closer look on what is this formula all about. The Polygon Angle Sum Formula is a vital part in describing the characteristic of a polygon. This is the formula for the Polygon Angle Sum. Using this formula, we can get the sum of the measurements of all the interior angles of any polygon. In the formula, the variable n refers to the number of sides for any given polygon. Once we get n, we can solve for the sum of the measurements of all the interior angles of a polygon. The second part of this video is where we talk about the mathematical basis for this formula. The Polygon Angle Sum is based on two different concepts. Mainly, it anchors on one important theorem in geometry, which is known to be the Triangle Angle Sum Theorem, which tells us that for any given triangle, whether it's an isosceles, right, or scalene, the sum of the measurements of all interior angles of a triangle is 180 degrees. Knowing this, we can use this concept later on as we derive the formula. Aside from this theorem, we also need to understand what are the diagonals of a polygon. A diagonal of a polygon is a line segment that can be drawn by connecting any two non-consecutive vertices of a polygon. Let's say in this quadrilateral, the first diagonal I could make is this line here. The other diagonal is connecting the other two non-consecutive vertices. For a quadrilateral, there are only two diagonals. Let us try to consider another figure. This pentagon here. There are 5 diagonals for this given pentagon, and they can be drawn in this manner. But we are not going to use all the diagonals of the polygon. We are just going to pick one vertex and all the diagonals that can be drawn from it. For this quadrilateral, let's use this vertex, and hence we only have this diagonal. For the pentagon, choosing this vertex will only have these 2 diagonals here. Why is it that we are going to use this? Because by doing this, we could come up triangles that can be formed in each of these 2 polygons here. Examining further the triangles that were formed, we can say that the sum of the measurements of the angles for each triangle in this quadrilateral are separately 180 degrees. For the pentagon here, examining that there are 3 triangles formed, then separately, there are 3 180 degrees which corresponds to 3 different sums of interior angles. We are going to use these 2 figures later. The third part of this video is when we are going now to see what the trick is in deriving this formula. Again, as mentioned, we are going to use the 2 figures earlier. Let us try to compare the relationship between the number of sides and the number of triangles that are formed in each of this figure. Let's start with the simplest polygon. The polygon with 3 sides is a triangle. In short, there's only one triangle that can be formed, and per triangle angle sum theorem, the sum of the interior angles is 180 degrees. Going to the next polygon, which is a quadrilateral given here, there are 2 triangles that were formed, and hence the sum of the interior angles is the sum of two 180 degrees. For the pentagon, which has 5 sides, there are actually 3 different triangles that can be formed in this figure, and hence there should be 3 180 degrees that can be summed up to complete the whole. Let us add another polygon here, a hexagon. A hexagon has 6 sides. If we are going to pick a vertex here and draw the diagonals, we could actually form 4 different triangles. 1, 2, 3, and 4. Again, 4 different triangles. And just simply following the pattern, the sum would have 4 different 180 degrees added to one another. Notice that we are just looking at patterns in this derivation. Speaking of patterns, let us look into the relationship between the number of sides of a polygon and the number of triangles that can be formed using the concept of diagonals from a singular vertex. For the first polygon, a triangle, it has 3 sides, and the number of triangles that can be formed is of course only 1. The relationship between a 3 and 1 is that the number of sides has 2 more than the number of triangles that can be formed. Or we could also say that from 3 to 1, the difference is just 2. We can notice that this pattern is also true with the other polygons. For a quadrilateral, a polygon with 4 sides, there are only 2 triangles that can be formed. Hence, the difference is just 2. For a pentagon, the number of sides is also 2 more than the number of triangles, or in other sense, from 5 to 3 is actually a difference of 2. And of course, for the last polygon, 6 to 4, the difference is 2. Looking into this perspective, we need to apply the same pattern as we go through the general concern. Now, the number of triangles formed here also signifies the number of 180 degrees that can be added to get the sum of all the interior angles on any polygon. For triangle, there's only one triangle that can be formed, hence there's only one 180 degrees. For a quadrilateral, which has 2 different triangles, there are 2 180 degrees added to each other. And the pattern goes on. For pentagon with 3 triangles, 3 180 degrees, and for hexagon with 4 triangles, 4 180 degrees. Same thing, the same pattern should also be true for a general formula later. With this trick, we can now determine what is the secret in this formula. Let us now try to get a general form of the formula for any polygon with side n using the 2 patterns we have seen earlier. The first pattern is where from the number of sides to the number of triangles, the difference is 2. In short, one triangle for the first polygon can be written as 3 minus 2. The 2 for the second is actually 4 minus 2. The 3 can be written as 5 minus 2, as well as 4 to be 6 minus 2. With this pattern, the number of triangles that can be formed for any polygon with side n must be n minus 2. Now let's go to the second pattern. We have learned that the number of triangles formed is the same as the number of 180 degrees that can be added. The first 180 degrees can be rewritten as 1 times 180 degrees. The second can be rewritten as 2 times 180 degrees in a shorter manner. The next, there are 3 180 degrees. We can write it as 3 times 180 degrees. And the last could be written as 4 times 180 degrees. As you can see, when we connect the second column to the third column, we are just simply multiplying the number of triangles formed by 180 degrees. So going to the general number of triangles that can be formed for any polygon with side n, and that is actually n minus 2, to get the total or the sum of the interior angles of the polygon, we just simply need to multiply n minus 2 by 180 degrees. This is actually the formula for the polygon angle sum, which is true for all polygons with side n. We simply looked at the two patterns and we have now this general formula. So this is now the formula for the polygon angle sum. Let us try to use this to solve a specific problem. This problem here is given to be what is the sum of the measures of the interior angles of a heptagon, and we know that a heptagon has 7 sides. To do that, we are just simply going to substitute n for 7 and do the mathematical operations to get the sum, which is 900 degrees. If you're not yet sure with this formula, then let's try to use a heptagon here, and let us draw the diagonals from this vertex. And as we can see, there are 5 different triangles that can be formed. This is actually in connection to the second to the last step of the process here, which shows the product of 5 and 180 degrees, which stands that there are 5 180 degrees for a heptagon. With this formula can now be used for any type of polygon. Now, let us answer the pre-test questions as our post-test. Number 1. In the formula, what does the variable n represent? Is it A, the number of diagonals, or B, the number of sides, C, the sum of the interior angles, or letter D, the measure of sides? 5 seconds. Time is up. Question number 2. Which theorem states that the sum of the measurements or measures of the interior angles of a triangle is 180 degrees? Is it A, the triangle angle sum theorem, or B, the Pythagorean theorem? How about C, the exterior angle theorem, or letter D, the isosceles triangle theorem? 5 seconds. Post-test question number 3. What term refers to a line segment that is drawn by connecting any two non-consecutive vertices? A, side, B, leg, C, base, D, diagonal. 5 seconds. Time is up. Second to the last question. In the derivation process, what is the relationship between the number of triangles formed and the number of sides of a polygon? A, the number of sides is 2 more than the number of triangles formed. B, the number of sides is 1 more than the number of triangles formed. C, the number of sides is the same as the number of triangles formed. Or letter D, the number of sides is 2 less than the number of triangles formed. Time is up. Last question for this video. What is the sum of the measures of the interior angles of an octagon? Is it A, 180 degrees, B, 360 degrees, C, 1080 degrees, or letter D, 1440 degrees? Time is up. I do hope you have learned from this video as we were able to determine the secret in the formula of the polygon angle sum, which stands for S is equal to the product of n-2 and 180 degrees. For more videos similar to this one or other mathematical concerns, you may scan this QR code here. Get your phones now, scan this with your QR scanner, and if you may, please subscribe on the channel. See you in the next videos. Goodbye.